The topic is finding absolute extrema of functions of two variables. So before we do the example, let's read the definition. To find the absolute maximum and absolute minimum of a continuous function f on a closed bounded set D, first we need to find the values of f at the critical points of f in D, and second we need to find the extreme values of f on the boundary of D, and then the largest from step 1 and step 2 is the absolute max value. The smallest of these values is the absolute minimum value. Alright, so let's do this example. Find the absolute maximum and minimum values of f on the boundary D equal xy. X is between -2, 2, y between -1 and 1. Our function, forgot to write it down, f of xy is equal x squared plus 3y minus 3xy. So that's a given. Alright, so first thing we do start with step 1. Step 1 says find the values of f at the critical points of f in D. So how do we find the critical points? We have to find the partial derivative with respect to x and partial derivative with respect to y, set them equal to 0 and solve for x and y, and those are considered the critical points. So partial derivative with respect to x will be 2x minus 3y, and then partial derivative with respect to y will be 3 minus 3x. Let's set them equal to 0. I'm starting with this because it's easier with partial derivative with respect to y. This means that x is equal minus 3 over minus 3 is 1. Now we need to set this equal to 0 and solve for y. Now we found already x, so y is equal, this means y is equal what? Minus 2x over -3, right? Or 2x over 3. This means that y is equal, we know the x is 1, so 2 times 1 over 3, so 2/3. Now our critical point will be x equal 1, y equal 2 over 3 is a critical point. So what do we need to do? Read 1. Find the values of f at that critical point. First of all, we need to make sure it's in our boundary. So the boundary will be right here. X is between -2 and 2. Y is between -1 and 1. It is in there. 1 2/3 will be here. So it is in our region D, right? This is what we mean with D. Alright, so I'm not gonna evaluate it now, I'm gonna leave it last. So we need to evaluate f of 1, 2 over 3. What else? Now number 2, it says find the extreme values of f on the boundary of D. How many boundaries we have? Let's call this boundary from here to here L1, this boundary L2, this boundary L3, and this boundary L4. So I'm going to do it a little bit differently. First, I'm going to evaluate the function at these corner points. So this point will be what? 2, negative 1. This point will be 2, 1. This point will be negative 2, negative 1. And this point will be negative 2, 1. So we need to evaluate f of 2, negative 1, f of 2, 1, f of negative 2, 1, and then f of negative 2, negative 1. We're going to evaluate all this, the function at all these points in the end. Now, we start with L1. So, what do we need to do? First, we need to find the equation of L1. Equation of L1 is y equal negative 1. So, on the boundary, let me write, on the boundary L1, actually the equation is y equal negative 1 and then the x is between negative 2 and 2. I'm not including negative 2 and 2 because I already evaluated the function at the corner points, right? So now we need to evaluate the function along this boundary. So z will be equal f of x. The y is going to be negative 1, which means wherever I see, I'm going to go to my function. Wherever I see y, I'm going to plug in negative 1, right? So this will be x squared plus 3 times negative 1 minus 3x times negative 1. So z will be equal to x squared plus 3x minus 3. Right? Now what do I do there? All I need to do, because I'm already took care of the point at the corner point, at the end points of that boundary L1. So all I need to do is calculate the derivative and see if I can find any critical numbers. So dz dx will be 2x plus 3. Yes, I do. If I set this equal to 0, my x will be negative 3 half. Now I know my x is negative 3 half and I know my y is negative 1. So another point, potential point where we might have absolute max or absolute min will be negative 3 half, negative 1. So I need to evaluate f of negative 3 over 2, negative 1. Now on the boundary L2, the equation of the boundary will be x equal to, and y is between negative 1 and 1. Again, I excluded negative 1 and 1 because I already include those corner points. Now, how do we find the we need to evaluate the function along that boundary. So z will be equal f. My x this time is 2. My y varies. So this will be equal. Now wherever I see x, I plug the 2. So that would be 2 squared, which is 4, plus 3y minus 3 times 2 times y. So my z happens to be 4 plus 3y minus 6y, so 4 minus 3y, so minus 3y plus 4. Now let me do it here. So dz dx is equal to -3. So therefore, no critical numbers on that for that function. No critical numbers. So on the boundary of 2, we're done. We have no potential points, or no points that are potential to absolute max or absolute min. Now, on the boundary L3, right? L3, right there. L3, the y is equal 1. Y is equal 1, and then x is between -2 and 2. So we need to evaluate the function along this boundary. Z will be equal f of x vary, but y is equal 1. Which means wherever we see y, we're going to plug in 1. So this will be x squared plus 3 times 1 minus 3x times 1. So z will be equal to x squared minus 3x plus 3. Now we need to take a derivative of z with respect to x. See if we find any critical numbers. Of course we do. So this is going to be 2x minus 3. Set it equal to 0. So x is equal 3 over 2. Now I know my y is equal 1. So the point is going to be 3 over 2, 1. So I'm going back here and I need to find f of 3 over 2, 1. Now on the boundary L3, on the boundary L4, we need to find the equation of the boundary L4. Where is L4? L4 is right here. The equation of that segment will be x equal -2 and y is between -1 and 1. So again, we need to evaluate the function along this boundary. Z will be equal f. My x is -2. My y varies. So wherever I see x, I'm gonna plug my -2. So that would be -2 squared plus 3y minus 3 times -2y. So my z will be equal to 4 plus 3y plus 6y. So z is equal 9y plus 4. This means dz dx, dz dy, is equal 9. So no critical numbers. By the way, did I mess up somewhere else? Yes. This is going to be dz dy. Right? Alright. So I think that's it. How many points we have? 1, 2, 3, 4, 5, 6, 7. Alright, so now we need to plug into the original function. We need to plug those points into the original function. So f of 1 2/3 is going to be 1 squared. I'll just evaluate at least two of them. 1 squared plus 3 times 2 over 3 minus 3 times 1 times 2/3. This is an easy one. Simplify these. This will be equal 1 plus 2, 3 minus 2 is 1. Right? So the same thing, we're going to evaluate all the other ones. I already did them. Why are we going to waste time? So f of 2 negative 1 is going to come up to be 7. F of 2 1 will be 1. F of negative 2 negative 1 will be 13. F of negative 2 negative 1 is negative 5. F of negative 3 over 2 negative 1 will be negative 21 over 4. F of 3 half 1 will be 3 over 4. So what's the largest number? So the largest number, so that will be the absolute maximum. And what's the smallest number? 21 over 4 is what? 5 point something. So negative 5 point something. So this will be the absolute minimum. And that's it for this example.